Today we are going to learn about mastering custom loss functions in PyTorch. You'll gain the skills to design and integrate custom loss functions into PyTorch models effectively. Welcome to our video on mastering custom loss functions in PyTorch. Loss functions are a fundamental component in training neural networks, acting as a guide to minimize the difference between predicted and actual outcomes. While PyTorch offers a variety of built-in loss functions, there are scenarios where custom loss functions are necessary to meet specific requirements. In this video, we will explore why custom loss functions are important, how to create them, and how to integrate them into your PyTorch models. By the end of this video, you will be equipped with the knowledge to effectively design and implement your own loss functions. Let's dive in.
Loss functions are crucial in the training of neural networks. They measure how well the model's predictions match the actual data. The goal during training is to minimize this loss, which in turn improves model accuracy. Loss functions are intimately tied to optimization algorithms, which adjust model parameters to find the minimum loss. Common loss functions include mean-squared error for regression tasks and cross-entropy loss for classification tasks. Understanding the role of these functions helps in choosing or designing one that best suits the problem at hand. This foundational knowledge sets the stage for exploring custom loss functions.
While built-in loss functions cover a wide range of applications, they may not fit all scenarios. Custom loss functions are essential when the problem requires specific error measurement or the inclusion of domain knowledge. For instance, in medical imaging, we might prioritize specific types of errors over others. Custom loss functions allow for such flexibility, enabling models to focus on what's most important for the task. They can also lead to improved accuracy by tailoring the model's learning process to the nuances of the data. Understanding when and why to use custom loss functions is a crucial skill for any data scientist or machine learning engineer. Creating a custom loss function in PyTorch involves understanding how PyTorch's autograd system works, as this will automatically compute the gradients during backpropagation. Start by defining the loss computation in a new Python function or class. Implement the forward pass, which calculates the loss value given the model predictions and targets. It's crucial to test the loss function extensively to ensure it's computing the expected values and is compatible with PyTorch's autograd. By following these steps, you can create a custom loss function that integrates seamlessly with your training loop, providing the flexibility needed for specialized applications.
PyTorch's autograd is a powerful tool that automatically computes gradients required for backpropagation. When integrating custom loss functions, ensure the function is compatible with autograd by using PyTorch operations that support gradient tracking. The backward pass, which is automatically handled by autograd, updates model weights based on these computed gradients. If issues arise, such as gradients not being computed, it often relates to non-PyTorch operations within the loss function. Debugging involves checking the computational graph and ensuring all operations are differentiable. Mastering this integration is key to leveraging the full power of PyTorch in custom scenarios. Custom loss functions must handle edge cases and ensure numerical stability to avoid training issues. Edge cases can arise from unexpected value ranges or data types. To maintain stability, consider using functions like torch.clamp to limit values and avoid overflow or underflow. It's also vital to test the loss function with a diverse set of data inputs to uncover potential issues. Techniques like gradient clipping can help prevent gradient explosion, a common problem in deep networks. Addressing these concerns ensures that your custom loss function performs reliably across different scenarios and datasets. Debugging custom loss functions can be challenging, but understanding common issues helps streamline the process. One frequent problem is incorrect gradient flow, which can be diagnosed by inspecting the computational graph. Tools like PyTorch's TorchViz can visualize the graph to identify breaks or incorrect operations. Validate your loss function with known examples to ensure it computes expected values. Iterative refinement, where you progressively test and adjust the function, is often necessary. Understanding common pitfalls and employing systematic debugging techniques will improve the reliability and effectiveness of your custom loss implementations.
Performance is a critical factor when designing custom loss functions, especially in large-scale applications. Optimizing for speed involves using efficient PyTorch operations and minimizing computational overhead. Profiling tools can help identify bottlenecks in your loss function, allowing for targeted optimization. It's important to balance performance with accuracy, ensuring that speed improvements do not compromise the function's effectiveness. By focusing on efficient coding practices and utilizing PyTorch's capabilities, you can create custom loss functions that are both fast and accurate, suitable for real-world applications. Custom loss functions are widely used in specialized domains to address specific challenges. In medical imaging, custom losses can prioritize certain types of errors, such as false negatives, over others. In object detection, loss functions might combine multiple criteria, like location accuracy and class confidence, to improve detection performance. In natural language processing, sequence-based loss functions can enhance translation accuracy. Case studies demonstrate how these custom loss functions significantly impact model performance, offering tailored solutions that outperform standard approaches. Understanding these real-world applications highlights the importance and effectiveness of custom loss functions in various fields. In conclusion, mastering custom loss functions in PyTorch is a valuable skill that enhances your ability to tailor models to specific problem requirements. We've covered the importance of loss functions, the process of creating and integrating custom ones, and techniques to handle common issues. By understanding and implementing these concepts, you can improve model performance across various applications. We encourage you to experiment with designing and refining your own loss functions, leveraging PyTorch's powerful tools to optimize your models for success. Thank you for joining us, and happy coding!